GM, how we doing, everybody? Welcome. Sorry, I just turned my my fan off below me. Welcome to the TSender kickoff. Just want to make sure that we're actually live here. Unlisted, we're unlisted, aren't we? Okay. Let me fix that real quick, because nobody is currently watching this, because this is currently unlisted. So I'm here all by myself. Oh, wait, there are 5 people here. How are there 5 people here? How are you all watching this? We're currently unlisted. I didn't make this public. Unlisted, public, done, save. And now we're public. How are you all watching? We have the link in the announcement. Aha, I see. Okay, welcome. We have the link in the announcement. Excellent. Excellent, excellent. Okay, so now we're actually public, so people will actually be able to show up here. Codebase is live, and we're going to be looking at some crazy TSender Huff code here. I'm very excited to go through this, because this is probably one of the craziest code bases any of y'all will ever see. And it's pretty minimal, which is really fun. It's pretty minimal, but it's pretty crazy at the same time. A lot of amazing stuff here. Okay. Welcome to the video. Welcome. All right. So I'm going to explain what this code base is, what it's doing, and what's going on here. I'm actually just going to jump right into the code, because I think that's going to be the best way to do this. Let me actually go ahead and share my screen here. Okay, lovely. Here's the README. Boom, TSender. This is our wonderful Dolly created logo here, our AI created logo here. So you can see all the stats of this contest here. It's a pretty small prize pool, $15,000. However, the dollars per line of code is pretty high, right? So the end slot is 256 here. So let me pull up my little calculator. So we do 1,500 divided by 256, about $50 or $60 per line of code. And most of the lines of code are just a single opcode. So we've got a pretty badass ratio here. Here is what this code base is about. It is and let me scroll down to the about. It is a hypergas efficient smart contract for airdropping tokens to a large number of users, inspired by the Gaslight team. That is it. This code does one thing. That's it. All it does is send tokens to multiple users. And if we go into this source, if we go into the reference contract, if this, what do I gotta do? I'm gonna follow the README in a minute. This is what the entire code base would look like. 2 functions, airdrop ERC20, are list valid. This is the entire code base. If this was just written in Solidity, this would be it. 2 functions. This function up here, it sends ERC20s to a number of recipients in a for loop, and then it has some safety checks in here as well. And then this are list valid just checks that your list of recipients and your list of amounts are valid. It just does some safety checks. That's it, right? So these are the 4 parameters that this function does. It takes the token address, the token you want to send, a list of recipients, a list of amounts, and then the total amount that you're expecting to send. That's it. And for a normal project, this is all there would be. Just this single little contract, this tiny little 2 functions things. But this is not a normal audit at all, a normal security view. Why? Because that isn't the contract you are auditing. This is the reference contract. And what do I mean by reference contract? I mean, this is the code base that you're going to reference of what it's supposed to do in Solidity. So this is the high-level implementation of the TSender code base. Why did we implement this in Solidity first? Well, because we took this code base and we made it more gas efficient than this. We said, hey, Solidity, not quite where we want you to be. We want you to be much cheaper gas-wise. And if we go into the README again, we can actually scroll down to actual gas costs. We can scroll down to like, maybe sending to one recipient. We can say, hey, 57,000 gas, that's too much. We would like to save 1,000 or 2,000 gas. We want this to be hyper gas efficient. So we said, we're going to re-implement this into Yule and inline assembly. And that's where we get this TSender code base. This is written in Solidity and inline assembly. And it does the exact same thing, exact same functionality as the TSender reference, except this is written in assembly. Now, this code base was heavily inspired by and mostly actually pulled from the Gaslight drop from Pop Punk LLC. We made some changes to the code base so that it suited our needs. But definitely go check them out. They do some really good work. This is like vectorized Pop Punk. They do some good shit. They wrote this in assembly and they said, hey, we're going to make this more gas optimized. And so here's the code base. It's the exact same thing. Airdrop ERC20, the 4 parameters. And then if we scroll down, it has this exact same RList valid. Now, RList valid isn't more gas optimized. I didn't do some super clever for loop to validate the loops because this is going to be these are going to be a pure function, right? So we don't really care about this being gas optimized. We're going to call this beforehand. We're going to call it, make sure it actually works. And oh yeah, thank you, Equius. We're just going to call it, make sure the recipients are good. We're going to static call it, and then we're going to call the actual function with that. So this will never spend gas, so I didn't really care to make gas optimized. This, however, we want to be super gas optimized. So we said, hey, let's write this in assembly. We'll make it more gas optimized, blah, blah. This code base is part of the audit. We want to make sure this is good. We want to make sure this works. We want to make sure all the safety checks that we implemented work correctly. And I'll talk about those in a little bit. But that's not even the whole story. We said, hey, you know what? That's still not gas optimized enough. So we re-implemented this in Huff. And here's the Huff code base. It's pretty dang badass, written by myself, Alex Rohn, and Gio from the Cyfrin team. And it does the exact same thing. If we scroll down to the main macro, it does the exact same thing. We ignore having value being sent. That's one of the checks we have. We have the airdrop ERC20 function with the exact same parameters, and it should do the exact same thing. And then we also have the RList valid as well. So we've implemented this code base essentially 3 times. Once in raw Solidity, once in Solidity in Yule, and then once in Huff. Now, part of the difference between the code base here that we created and the Gaslight code that they created is we've added a lot of additional safety checks. And I'll talk about those in a little bit. But to make sure our code base was more gap optimized than theirs, we created this TSender nocheck.huff, which kind of matches the functionality of theirs. Theirs had fewer safety checks. So this has fewer safety checks as well, but this has no safety checks basically. But it's still the same functionality, just without the safety checks. So this is what we'll use to reference to the Gaslight codebase, which doesn't have safety checks. And this is what we'll use to say, hey, like, here's how much more gas optimized ours is, and here's why. So in scope for this audit, again, I'll talk about the safety checks, is tsender.sol or tsender.huff. So that's the Huff implementation with safety checks. tsender.sol, that's the Yule implementation with safety checks. and TSender underscore nocheck.huff. That is the Huff implementation with no safety checks. So what are these safety checks that we've added to here? So TSender, all of the code bases with safety checks. That is the tsender.sold and the tsender.huff, and obviously the reference as well. We check that the total amount parameter matches the sum of amounts array. So in our code base here, we want to make sure that the sum of all the amounts matches the total amount we expect, right? And so if we scroll, and the reason for this is we actually do a transfer from, where we transfer from all the tokens, and then we loop through this list. Maybe I should show you guys the reference. Yeah. And then we loop through this list. Where's the list? And then we loop through this list and we add up the amounts. And then at the end, we check, hey, does that amount actually match? Why do we do this check? Well, because if we transfer all the tokens to this contract and we don't transfer them out, they will get stuck, right? Obviously, question comes up, oh, well, this won't work with fee on transfer tokens. Yep, there's a whole bunch of known issues. We're not going to use fee on transfer tokens with this. These are the expected token integrations. If any of those have an issue, obviously, except for like, oh, USDC like doesn't upgrade and they add fees, which they totally could do, but we're going to ignore that for now. Anyways, so that is the first check. Next, doesn't allow ETH to be sent with function calls. So all of these are non-payable. So they have a check where you're not allowed to send ETH to these. Make sure the total lengths of the amounts array and recipients array are the same. So these two arrays should be the same. All of these tsender reference, tsender.soul, and tsender.huff, they should all have a check for that. And checks for 0 address recipients as well. So in each one of these, they have like a little if recipients equals address 0, it's going to go ahead and revert. Now, additionally, we didn't want to spend the gas actually doing these checks. So we added this additional function, rListValid, that has basically additional checks and will run these two lists through rListValid before calling airdrop ERC20. So the checks in here are going to be looking for duplicate addresses. Once again, looking for 0 addresses, making sure there's at least one recipient, making sure all amounts are greater than 0, and then requiring recipients.length equals amounts.length. So there is a little bit of redundancies in the checks here. That's fine. But the biggest one is the duplicate addresses. Like I said, I did kind of this crappy implementation where we just did like a double for loop, which is like horrible. But it's fine because nobody's actually calling this with gas. So like whatever. You can see some of the gas comparisons with the Gaslight team. Definitely give them a shout out, give them a follow. They do some really cool stuff. Yeah, Vectorize, Pop Punk, and friends. Their code base does not have the safety checks. So this is why we made tsender nocheck.huff to compare with them as well. You can see some of the stats. They'll probably be a little bit different when you run them. But the code that we are going to be deploying is tsender.soul. This will be deployed to ZK Sync, and you all should do an amazing job auditing this because we're going to send you guys money through this contract. So if there's something wrong, you won't get paid. So you should audit this well so that you can get paid. So tsender.soul, we are going to be deploying to ZK Sync Air. So this is production code. This isn't, some people ask me, hey, is this a first flight? No, this is going to be production code that we're going to deploy. Now, Huff or raw EVM codes doesn't work on the ZK Sync chain, which is why we're going to be deploying tsender.soul to ZK Sync. So for EVM equivalent chains or more equivalent chains, we will be deploying the Huff. So this is this code base, and we're going to be deploying them to Ethereum, Arbitrum, Optimism, Base, and Blast. So we will be deploying to those if we decide to do payouts on one of those chains, or just as kind of like a public good for people to use like this crazy gas optimized code base. We will additionally actually be deploying tsender nocheck.huff to those chains as well. And on the UI, we're going to have like oh, do you want like the super gas optimized experience? Try this one. But like, just keep in mind, uh, you know, it's going to destroy your code base if you're going to lose all your money if you screwed up. We're going to highly, recommend people use the ones with the checks. But if someone just says F it, like I want to just send it and I want it to be super gas optimized because I'm a masochist, so be it. Random question, but what's the little star symbol on the code line? What's star symbol? If you let me know what star symbol, I can let you know. Are we accepting gas severities for this? Hadn't really thought about it. We are not. However, if you want to make a PR and you want to be one of the authors on this code base, where you can say, hey, like I helped make the most gas optimized airdropper code base on the planet, PRs are welcome. And then you'll just get to be a badass. So we're going to be promoting this as like the super most gas optimized airdropper on the planet with safety checks as well. All the Huff lovers are here. Love to hear it. The Copilot icon. Yeah. So the Copilot icon. Cool. There's some notes down here. There is an issue right now where with Foundry ZK Sync. So this is kind of an interesting project for a lot of reasons. One of the reasons it's interesting is that we are working with ZK Sync. ZK Sync is not EVM equivalent. This is why Huff actually doesn't work. I have some ZK Sync assembly notes in here. They're not part of the code base or anything. They're just kind of like, oh, wow, that's interesting. Where like your Solidity compiles down to, so this hi.sol compiles down to this hi.zasm. So this is the assembly. This is the Huff, if you will, of ZK Sync. It's very different. It looks nothing like EVM. But this is why we can't. Sorry if you can hear the garbage truck outside. But that's why we don't actually deploy the TSender.Huff to ZK Sync, because they are not EVM equivalent. They're EVM compatible. This is where the Solidity actually compiles down to their ZASM correctly. The Huff doesn't. Anyways, it's important to know this because when working with ZK Sync, we actually need to install the Foundry ZK Sync edition. And this is what will actually help you compile all your Solidity to the ZK Sync, opcodes and whatnot. So you'll get this ZK out folder once you compile it. Oh, actually, let me just go through the README real quick. Getting started. We'll want to run make to get everything installed. And I currently just have regular Foundry installed, which is fine to get started and for doing all your testing. Once you finish, I have Rust log equals debug. Well, sorry. Once everything is installed, you can run, forge test, make test, whatever you want. And then you're going to actually have to switch over to the ZK Sync Foundry, and you're going to have to delete a couple of files in order to work with ZK Sync Foundry. And we talk about those at the bottom. You have to you have to basically delete anything that has anything to do with Huff, because the ZK Sync Foundry has a really hard time understanding what's going on. But once you have everything installed, you can run forge test or make test, and this will run kind of this ridiculous test suite. And I love it because of how ridiculous it is. If we go to tests, the biggest thing here is we have our base test, which is an abstract contract, which every single one of these runs on. Every single code base runs on this base test code base. If we go to unit tests, we've split them into has checks and no tests, or has checks and no checks. We can see all they do is they inherit is base test, and we just say whether or not they have the safety checks. And then in this base test file, we have this little has safety checks, and we basically check in each contract, do you have the safety checks? If yes, we're going to run this test, assuming you have the safety checks. If no, we're going to run it, assuming you don't have the safety checks. And that's how we know whether to test for the safety checks or not. These tests take a little bit to run because they were all fuzz tests, which is super fun. Then we went one level farther. So we tested all these. We did all these kind of equivalence tests. Then we additionally formally verified with this all with Halmos, which is a lot of fun. So kind of above each one of these functions, we have a little command here to show you how to run each one of these formal verification bits in Halmos. In the makefile, we also have this make Halmos, which runs kind of all of them like this. There was an issue with Halmos where it was having a hard time running it not like this. So this is how we're doing the Halmos stuff. So if we want to do like a Halmos test, you need Halmos installed, obviously, but then we can go ahead and run this. This will go ahead and run the formal verification. And these are really cool and really important because they make sure all the different contracts do exactly the same thing, especially for the ones with checks. So some of the ones that I think are the most cool, the most interesting are, there's also some fuzz equivalence tests in here as well. I think some of the fuzz equivalence tests are really interesting. And then I also think that this one is really interesting because we're sending, this is R list valid. No, I don't care about R list valid. Yeah, I think this is one of the more interesting fuzz tests. If you can figure out how to do this with Halmos without it breaking, that would be really cool, because this is like the fuzz test or the formal equivalence test where we're saying, hey, on any call data, all of these code bases return basically the same thing. They error at the same time, they revert at the same time. We want to make sure that they are truly equivalent. So, yeah. Any other notes, I guess? Compilation takes a long time, especially when working with Foundry ZK Sync. Once you work with Foundry ZK Sync, you will get a ZK out folder. It's basically the same thing as out, it's just with the ZK Sync compiled code bases. Any other notes? Yeah, these are the tokens we're expecting. Known issues. Yeah, it doesn't work with fiat and transfer tokens. We do not check the return value of transfer from and transfer, meaning an ERC20 returning false on a failed transfer from, ERC20s that return false on a failed transfer from but successfully execute are not supported. Those are not tokens this will work with. Upgradable denial lists can prevent this contract from working. We expect that. In the case, any recipient is on a denial list, the entire transaction will revert. But like I said, these are the tokens we're expecting this to work with. There's some other notes in here. Happy to take questions now. So if you scroll down, you can kind of see there's a pretty substantial gas improvement for one airdrop using Huff or Huff no check. Once you get into the larger amounts, the Huff is only slightly more gas efficient than like Gaslight, right? Which makes a lot of sense because a lot of the assembly is pretty optimized. There's like a single opcode where the Huff is better, and it's a lot of the startup stuff in the Huff that's better as well. Like, for example, like this, we save like a dupe opcode call because we're not we don't run the dupe here, right? And that's something that Solidity would do. There's a bunch of just super tiny optimizations that we do in the Huff that doesn't happen in Solidity. So any questions? Is there any idea to make a video on building the most gas efficient airdropper on the planet? So I actually streamed most of me building this on YouTube. So if you head over to my YouTube, you can find me streaming building most of this. I mean, it's really not that interesting though. It's mostly me like sitting here, staring at this Huff code, going, okay, how the hell do I get rid of this swap, or how do I get rid of this pop, or how do I get rid of this mload or something like that. Like that's like most of the video. Any other questions? Great question. This is gonna be a fun one. This will be production code in Huff, which is why I think this is so fun. There's not a lot of production code in Huff, but this is a small enough code base where it makes sense. We're going for gas optimizations. Yeah, if you think you have a badass gas optimization, feel free to make a PR. This is an open source public good. So, and definitely be sure to give shout outs to the Gaslight team as well for inspiring a lot of this. Any other questions? Should be pretty straightforward. Do you plan to add new features in the future? There were thoughts of adding airdrop ETH to the contract. I decided against it because I'm pretty much never going to use that. Right now, no. Right now, this is it. Right now, it's done. Maybe in the future, if like enough people hit me up and be like, "Hey, Patrick, like give me airdrop ETH or something." Hell yeah, this is gonna be a fun one. Why are you like? Is that like some alpha? You're like, oh, it should be upgradable or something. No, that's not going to be a valid finding. Any other questions? Give it another 60 seconds, 20 seconds for questions. You can find me on Discord too. Hopefully one day I will be able to find better gas optimization. Hell yeah, I hope so. I hope so. I had an issue with fuzz testing with differential testing. Foundry fuzz runs 100 with exp.py. Any idea why? I don't know what exp.py is. Sorry, you might have to ask in the Discord. So should I start Web3 or not? Hell yeah, you should. Hell yeah, you should. All right, cool. Well, if there's no more questions, good luck. I hope you guys find some bugs so that we can make this super secure, super safe. And I feel like this is going to be a contest where there's going to be like some weird edge case I didn't think about. And I'm excited to learn. So thank you all. Good luck. Peace.